This is question 34 from the LO3 tutorial questions for engineering dynamics. In this question, we're doing a problem involving rotational kinetic energy. And just to be clear, the course notes often refer to this with the symbol here, KE subscript rotation. Quite often in my videos, and here I'll be using EK to mean the same thing, and either's absolutely fine in questions. So what are we working out here and what information have we been given? Well, let's start with what we've been given in the question. We've been told that the mass of the disk is 2 kilograms and the radius of gyration, so that's the value k, is 0.2 meters, and its angular velocity is 400 RPM. So let's see what we can do with this, because it's the moment of inertia I we're looking for. Well, and the rotational kinetic energy. So let's start with the moment of inertia. The moment of inertia, when we have the radius of gyration, is given by I is equal to m the mass times k squared. So we can put these in straight away and find it out. We've got 2 times 0.2 squared, which gives us 0.08. Remember, the units are kilogram meter squared. So we've got I. We can use I and our rotational, our angular velocity to find the rotational kinetic energy. But before we do, we need to convert omega, our angular velocity, into radians per second. And we do this by using our conversion formula, 2 pi times the value in RPM divided by 60, which gives us 41.888 radians per second. That's as an exact value there. Oh, sorry, to 3 decimal places, not exact value. The exact value in your calculator you can use in the next step. So we've got our formula for rotational kinetic energy, which is EK is equal to half I omega squared, where I is in kilogram meters squared and omega is in radians per second. So we put these values in, get a half times 0.08 times 41.888 squared, and I'm going to be using the exact value in my calculator to get the answer. Here's whatever I've got that comes after that. And putting all of those in, we're left with 70.184 joules as our answer. So again, maybe a slightly different value if you used a rounded answer rather than the exact calculator value for what we worked out for the value of omega there. But using exact calculator values, we get 70.184 joules as our answer. And remember, units, very important.